Okay, the next section is 2.8. We're going to talk about solving inequalities now in one variable. So we'll do polynomial inequalities, some rational inequalities, and other types like square root. And we'll do some application hopefully as well. Okay, so these polynomials are going to be some functions either greater than 0 or greater than or equal to or less than, and we need to find all the values that make that true essentially. So let's look at an example. Here's a cubic function. Now we know what this cubic function looks like. We know that, it goes through -3 and 4, and we know that it's got an odd multiplicity at -3, so that means it crosses the x-axis, and it bounces off at 4, because it's got an even multiplicity. So we know it looks something like that, and we can then easily answer where it's 0, positive, or negative. And this one's easy enough to graph in Desmos and do that as well. But there's a lot easier way to do it that I want you to learn, and you have to learn it because some of these are going to get much harder, and you're not going to be able to find out what those values are essentially, because a lot of them are going to have weird asymptotes that are at like fractions and stuff. And so the function will let's say do something like this. I don't know. And say this happens at like a weird fraction value that's hard to find. Then I want an exact answer. Well, you're going to need to make a sign chart for this. So please learn how to make a sign chart. It's not that hard. All you do is put the key points on a number line. The key points are zeros and undefined values. Those go on the sign chart. In this case, there are no undefined values, so you put on just the zeros, which are -3 and 4. Now what you do is you pick a number. By the way, label them, because they're both zeros. That's going to be important later when we get ones that are longer and more difficult. Pick a number that's less than 3, like -4. -4 gives you a negative here, and this is always going to be positive because any number squared is positive. So that gives you a negative. Pick a number between -3 and 4, like 0. When you plug in 0, you get a positive and a positive, so that's positive. Pick a number bigger than 4, like 5, gives you a positive and a positive, so that's positive as well. Now we can answer the question, when is this 0? Well, it's 0 whenever we're at these 2 points, -3 and 4. It's positive from -3 to positive infinity, if we're calling 0 positive, which we are. And we can include -3 because it's a 0. It's negative from negative infinity all the way up to -3, not including -3 because it's 0 at -3. It's easier to answer these questions in interval notation right from the sign chart, which is what we need to get used to. All right, here's another example then. Make a sign chart. Put the key points on here. The key points are -3, 5, and 2/5, so 2/5 and 5. Okay, this one's undefined value. This is a 0. This is a 0. Now find out what the valued function is. Below -3 is -4, gives you a negative, and a negative, so that'd be negative. Between -3 and 2/5, like 0, gives you a positive, a negative, and a negative. Gives you a positive. A number between 2/5 and 5, like 3. 3 gives you a positive, a negative, and a positive. So that'd be back to negative. A number greater than 5 is like 6. 6 gives you a positive, and a positive. So that'd be a positive. Okay, so now what we're looking for is where is this thing 0? Undefined, positive, and negative. Well, it's 0 at -3 and 5. It's undefined at 2/5. It's positive in this range right here, which would be from -3, I can include that because 0 is positive, all the way up to 2/5, but don't include 2/5. And also from 5, I can include 5, all the way up to positive infinity. And it's negative from negative infinity all the way up to -3, not including -3, as well as 2/5 to 5, not including either of those. Because it's not negative where it's 0, and it's not negative where it's undefined. Alright, so the sign charts make these problems really easy. We don't even have to know what this graph looks like. Okay, so make sure that we're getting used to making these sign charts. Here's another example where you can do the same thing. You have x cubed. If you add 8x to both sides, be x cubed minus 6x squared plus 8x minus 2 is less than or equal to 0. So we need to find the zeros of this polynomial then, which we've done before in this class by actually graphing, but we also use the rational zeros theorem, where we plugged in fractions of these coefficients, negative 2 and 1, and then found the rational zeros. So quickly graph this and find the rational zeros, or use the rational zeros theorem. Turns out the rational zeros are at 0.325, 1.461, and 4.214. So we could give our answers as decimals, which is unfortunately what it wants us to do because it says solve graphically. So we just want to look at this graph and determine when the bigger one, or when this one is bigger than the other one, or when this thing's less than or equal to 0, which is solving the same thing, right? It's less than or equal to 0 from negative infinity all the way up to 0.325. So it'd be negative infinity all the way up to 3.25. And I can include 3.25 because that's a 0. It's also less than or equal to 0 from 1.461 to 4.214. And I can include both of those because it's equal to 0 there. So that would be the two solutions that you get. Even if you graph both of these, this cubic and this line, you'd get these same points. Probably easier to graph when you put it into standard form, and then you're looking at a cubic when it's less than or equal to 0. All right, so let's do another example of a sign chart then, and then we can do some web problems that'll hopefully help as well. But on the sign chart go the places where this thing's 0, and also the places where it's undefined. So negative 3 is an undefined value. Negative 1 is a 0. And 1 is an undefined value. Okay, now pick some numbers less than negative 3, like negative 4. That gives you a negative in the top, negative here, and a negative there, which makes a negative. Pick a number between negative 3 and negative 1, like negative 2. Negative 2 gives you a negative here, a positive here, and a negative here, which makes positive. Number between negative 1 and 1, like 0. 0 gives you a positive there, and a negative there, so it'd be negative. Number bigger than 1, like 2, gives you a positive, and a positive, so that'd be positive. Now we can answer the question, where is this thing 0? Well, it's 0 at negative 1. Where is this thing undefined? That'd be negative 3 and 1. Where is it positive? That'd be from negative 3 all the way to negative 1. I can include the negative 1 because that's a 0. Can't include the negative 3 because that's undefined. It's also positive from 1 to infinity, and I can't include the 1 because that's undefined. Where is it negative? Negative from negative infinity all the way to negative 3. I can't include the negative 3 because it's undefined. It's also negative from negative 1 to 1, right here. And I cannot include the 0 because it's not negative. And I can't include the 1 because it's undefined. Okay? Let's just try one last example. This is a weird function. It's got a radical in it. We want to know when this thing's less than or equal to 0. So let's do a sign chart again. Let's put the key points on here, which are places where this is 0 in this case, or undefined. So 2 it gives us a 0. Also, negative 1 gives us a 0. So let's put on negative 1 and 2. And let's test this function in these regions. So pick a number that's less than negative 1, like negative 2. Negative 2 gives us a negative times, and then a negative 2 over here gives us a negative. So these are all undefined values. This is a 0, and this is a 0. But all of these values are undefined because they all give a negative underneath this radical. Now I'll pick a number between negative 1 and 2, like 0. When you plug in 0, you get a negative, and you get a positive here. So that would overall be a negative. Now I'll pick a number bigger than 2, like 3. When you plug in 3, you get a positive there and a positive there, so that'd be positive. So now I can answer this question, when is this thing less than or equal to 0? Well, that'd be this point right here, all of these points, and this point. So that'd be from -1 to 2, and I can include both of those things, so when it's less than or equal to 0. All right, let's try some web work problems. Hopefully we can get this figured out.